Okay, the final section of Unit 1 is 1.6 piecewise functions. Now, piecewise functions sounds like something new, but really it's not anything new. All we're doing with the piecewise function is putting multiple domain-restricted functions onto one graph. So for example, number 1 here, if we just look at that top equation, we've got the function x plus 3 quantity squared, but we only want that graph when x is less than -2. And then our other function is the absolute value of x minus 1, and we only want that function when x is greater than -2. So we can see here from looking at the domain restrictions that something pretty special is happening at x equals -2. That's where we're going to have a boundary line. Okay, so I'm going to use something bright here this time so we can see it really well. I'm just going to use a highlighter. And then I'm going to put a boundary line here at x equals -2. Now, we don't have to have a boundary line. It's just kind of a nice visual. I'm going to have one graph on this side and one graph on the other side of that line. But again, this is optional. You don't have to have it on there. Okay, and then how do we graph these things? Well, just like we normally would, we're just going to stop whenever we hit that line. So for the top one, the parabola, we've got the function x plus 3 quantity squared. That's going to be a parabola left 3. So we're going to move left 3 from the origin. And then there's our vertex. And then we can use our lattice points to get another point on these graphs. I'm going to go over 1 and then up my a value, which is 1. So over 1 and up 1. I'm going to have a point here. Over 1 and up 1, I'm going to have a point here. Now, anytime you plot a point on the line, it's probably a good idea to use an open circle, because it's always easy to fill in the circle, but you can't open it back up once it's filled in. Okay? And then let's see, my parabola is going to look like this. Okay, so it's going to be something about like that. It's going to go up to the left forever, but it's going to hit this line right about there. Okay, and then let's see. We only want this function when x is less than -2, not less than or equal to. So I'm going to leave that an open circle because we're not including that point. Okay, and then that's it for that part. And then the second function, we got the absolute value of x minus 1. So then that's going to be shifted down 1 from the origin. So then our vertex is going to be here at 0, -1. My a value, in other words, my slope is 1, so I'm going to go up 1 over 1, up 1 over 1, and we are going to hit that point again. And on the right side, it's just going to keep on going. So we're going to go up here and hit that point, and then it's going to go off in that direction that way. Okay, so then there is my piecewise function. And then last thing, do we need to fill in this point? Well, I only want this graph when x is greater than -2, not greater than or equal to. So even though both these graphs are going towards that one point, we're not including that point on our graph because neither one of these is or equal to. Okay? All right, so then there's the graph, and then we just want to state the domain and range. Okay, so what's the domain and range of my function? Well, the domain, just like with regular the regular functions, the domain restricted graphing, the domain is pretty much right here. Okay, so x can be less than -2 or x can be greater than -2. Can it actually equal -2? Well, no. So then we're going to have a union here. So the domain goes from -infinity up to -2, not including -2, and then we're going to union that with everything from -2 to +infinity. Okay, so then there's my domain. What is my range? What can my y values be? What's the lowest point on my graph? Well, that would be right here at y equals -1. And then, yeah, y can actually equal -1. That vertex is part of my graph. So then brackets around the -1. And it goes, well, don't even worry about the left side of the graph. This goes up and to the right forever. So I know y can be anything bigger than -1. So it goes from -1 to infinity. And that's my range. Okay, so these problems look a little funky. They look new and scary. But if you just break it up into smaller problems that you're doing all at once, they're not too bad. Okay, number 2. Okay, so where's our boundary line going to be here? Where's the special point here? Well, I want this graph when x is greater than or equal to -1, and I want this graph when x is less than -1. Okay, so then at -1, at x equals -1, that's where my graphs are going from one to the other. So then I'm going to put my boundary line there at x equals -1. And again, you don't even have to have that line on your graph. It's just a nice visual. That's where I'm going to have one graph on one side and a different graph on the other side. And then just look at these graphs individually. So we'll do the top one first. I want to draw the graph 3 raised to the x plus 1. Well, that's an exponential function, so then normally I'm going to have a point right here at 0, 1. And this is shifted to the left 1, so that's going to be right on my line there. So I'm going to put an open circle to start. Okay, and then an exponential curve. Normally it's going to kind of curve and go up real fast. We normally have the point 0, 1. We shifted it to the left. We also normally have the point 1, whatever our base is, which would be 1, 3. That's also shifted to the left 1 if we want to put a second point there. And then basically this thing just goes up really fast. So it's going to be a curve kind of like that. Let's see. We want that graph when x is greater than or equal to 1, so we can fill in this circle and make it a closed circle there, because we are including that point on this graph. Okay, and then our second function, -2 times the absolute value of x plus 2 plus 3. Well, this is shifted left 2 and up 3. So left 2, up 3. And then that's where my vertex is going to be for this. And then our a value, in other words, our slope, is -2. So I'm going to go down 2 over 1, which puts me on that point there, down 2 over 1 the other way. And we can do that again if we want to get some more points. And our v is going to look like this. Okay. All right, and then there is the graph of our piecewise function. Just a quick note, the two graphs do not always have to meet at the same point. That's just kind of coincidence on these first two examples. Okay. All right, next, what's my domain and range? Well, again, my domain is right here. X can be anything bigger than 1 or equal to 1, and x can be anything less than -1. Sorry, -1, not +1. So it can be greater than or equal to +1 and less than, said it again, sorry, greater than or equal to -1 and less than -1. In other words, x can be anything. It goes to the left forever. There's no holes in my graph, and it goes to the right forever. So my domain is all reals, from -infinity to +infinity. And then my range, let's see, this goes down forever. There's no holes in my graph, and it also goes up forever. So my range is also all reals. Y can be anything as well, from -infinity to +infinity. And now number 2 is done. Okay, so again, these aren't easy problems, but if you break it up into just a series of smaller problems, they're not so bad. All right, last one on the front page here. Number 3. All right, let's see. We want our top function when x is bigger than 1, so then that's where my boundary line is going to be, is at x equals +1. And then my bottom function is just the graph of the line y equals 4 when my graph is greater than or equal to -3 and less than +1. So I'm going to have two boundary lines here, one at +1 and one at x equals -3. Okay. And then again, just graph these one at a time. Let's start with the parabola on top. This parabola has a vertex at 3, 0, so we're going to be shifted right 3. And there's my vertex. And then normally we just draw two lattice points, over 1, up my a value, which is 1, over 1, up 1, and I would draw my curve. Okay? But we really need to know exactly where we hit this boundary line because that's an important point. Okay? So we might have to plug in x is 1 to our equation. If I plug in x is 1, well, 1 minus 3 is -2. -2 squared is 4. So I can go to 1, 4 and plot that point there. And since the parabolas are symmetric, we can put a matching point over here if we want to. Now, the other way we could have gotten that point is by using the pattern of a parabola with an a value of 1. I go over 1, up 1 squared, over 2, up 2 squared, which is 4. 1, 2, 3, 4. Either way, we get that same point. And now I can draw my parabola. I did make one little mistake. Hopefully you caught it. I put a closed circle, and this should have been an open circle. So I'm going to kind of exaggerate that a little bit and make it an open circle there. Okay, and then there's my parabola. And then next, we've got the line y equals 4 between the x values of -3 and +1. So y equals 4 is just a horizontal line up 4, so 1, 2, 3, 4. So it goes from here to here. There's my line. I want that line when x is greater than or equal to -3. So then I can fill in this side on the left, but only less than -1. So we do leave that an open circle there. Okay, and again, the graphs aren't always going to hit at the same point, but these three did. Okay, and then last thing, domain and range, and then we're done with the first page. What is my domain? What do my x values go from? Well, from here at -3 up to +1. So it goes from -3 to +1. Yes, it can be -3, so brackets around that. Open circle, so no, it can't be +1, so then parentheses around there. And then it also goes from 1 to infinity. So we got to union that with everything from 1 to infinity. So there's my domain. Okay, and then the last part, what is my range? Well, my lowest y value is right here at y equals 0. And yes, it can be 0, so we want brackets around that. And then it goes up forever, so it goes from 0 to infinity. And there's my range, and then that wraps up the first page.